hadirin yang berbahagia, Tuan Pengerusi Majlis, ladies and gentlemen, let me go straight to the presentation. I think you must have heard this morning, a lot has been deliberated. It was launched in quite a impressive manner. The guidelines which we have been working on for almost a year. But what I want to show in the afternoon session today is how do we make a sustainable construction of Malaysian peat. For those who are not familiar with peat soils, peat is an extreme form of soft soil. The organic content is generally more than 75%. And it is estimated that 1 billion acres of peatland in the world, and that is 4.5% of total land areas in the world are covered with peatland. This is some of the problems related to construction in peat. The pictures on the left, as you can see, is a school which has been constructed on peat. Over the years, subsidence have taken place. Of course, the building stays at the same place. It does not suffer vertical displacement because it is founded on piles. But other infrastructure which is not supported would settle vertically. And we have to wait for several more years, and probably the school has a free basement to go with it. Yeah? Of course, you will see situations like this would invite a lot of unpleasantries, like for example, it becomes a breeding ground for mosquitoes. The recent one I can relate to having similar problems is construction of KLIA2 on peatland, but not as extensive as in Sarawak. But the last few months it becomes a major issue because of the flooding of the taxiway. That is also problems related to construction in peat. Of course, there are ways to actually minimize problems related to construction on peat. This is an extreme one, as you can see, where buildings and infrastructure like drains are supported on piles, but other parts of the infrastructure are not supported on piles, and you have this differential settlement, and every year you have to keep topping up pavement to ensure that the inner roads are passable. The most unpleasant one, I think, a lot of building development, the most unpleasant situation if you have extreme subsidence, you probably see or probably experience situations where the sewer lines are severed from the main building, and that becomes a very unpleasant situation to live in. This is an exact example. As you can see, subsidence can be well above 500 millimeters, and this is causing a lot of distress on the struggling structures. And again, this differential settlement, as you can see, in some of the housing projects, and you can see this everywhere in Sarawak, mainly because as deep as 15 meters of peat can be found in Sarawak. I was just having a discussion with our counterpart in JKR Sarawak, and he was mentioning to me the maximum depth that he has encountered so far is 15 meters. And I've only accounted for 7 meters of peat in Peninsular Malaysia. Sites like these are quite common, very unpleasant, but we have to live with it. And probably it's quite close to where we are in Putrajaya, where 7 meters of peat, the construction of the flyover in 7 meters of peat actually caused a lot of movement to the embankments and finally caused major cost for the collapse of the flyover. Now let's look at the world distribution of peatland. If you look at in terms of percentage of the land area in one particular country, Finland tops it all. Finland has got a third of its country covered with peat, although it only has about 10 million hectares of peat. But that 10 million hectares, being quite a relatively small country, that 10 million hectares comprise of 30% of the total Finland as a country. That goes, if you look at Malaysia, we are looking at slightly below 10 million hectares of land covered in peat. And that constitute 40 million hectares, and that constitute only slightly less than 10% of our land area. Most of the peat distribution in the Peninsula Malaysia is actually along the coast. The east coast sides, I have experienced some construction works in peat in the east coast, and they are limited to only 1 to 2 meters of peat. The depth is not very severe, and what I would normally do is to remove all of them. Of course, it becomes a major environmental issues, but 2 meters of peat removal is not so bad. But if you go towards the west coast, where the peat can be as deep as 7 meters, you will not get the permission to actually remove all of them, and it's difficult to remove 7 meters of peat anyway. On top of that, below the peat layers in the west coast, you have soft marine clay, which you have to deal with, unlike the east coast where you have sand, which is friendly to the engineers. In the east coast, where our Minister of Works comes from, Cebu, we have a lot of peat. Most of the pictures which I showed earlier actually came from Cebu. And just to show you, Sabah is quite scattered in distribution of peat. Sarawak takes about 70% of the total peat in the country. Peninsula Malaysia with Sabah covers a total put together as only 30% of the total peat coverage. For those who are not familiar, I know some of you knows what peat is, how it is formed. Water is retained in the depression from nearby river. River flows and rainfall, and over the years you have organic matter, and 3 liter accumulates into the depression. Decomposition is slowed, poor aeration, and microbial degradation is retarded. I think you have probably heard that a lot of corpses that were found in peatland, they are very well preserved, because the decomposition is slowed down. And usually peat layer form after many years. It is estimated to between 2.5 to 4.5 millimeters per year. If you look at 2.5 to 4.5, you're talking about 100 years. You only get about half a meter. So you're talking about 1,000 years, that's only 5 meters. So peat, usually in most countries, has become a protected area. It becomes areas where construction is prohibited. But in Malaysia, being a small country, whether you like it or not, highways have to pass through. Peatland, and development has gone into areas where peat can be found. Peat classification scheme, I just go through some of the method of classification because we have presented this in the guidelines. I've shown a little bit of this, just basically on the basics of how peat is classified. It is usually based on the percentage of organic content, fiber content or ash content. Various methods have been looked at, but generally peat is considered by various classifications or various standards as having organic content more than 75% or ash content of about 25%. Perhaps the most popular method is that proposed by Von Post in 1924, which described peat by the degree of humidification, where you squeezed peat in your hands, and the degree of humidification can be determined by looking at how the behavior of peat when it is squeezed. Now we have gone through some of the basic formation and characteristics of peat. Let me go into to look at some of the design consideration and construction experiences of buildings and infrastructures in peat. This is quite a major problem for engineers when designing embankment or construction on peat. Bearing capacity is very poor. When you load a soft layer or peat, you will have bearing capacity failure where you have heaving on the sides, and sometimes you have, if you're building too fast, you probably get rotational slip surface because you are not allowing water pressure to actually dissipate from the system, and you're going to have rotational failure. This is a common side in most roads construction of a peat. Now, how do we ground improved effectively on peat? The first one on the right, which is R&R, we call it's not rest area, it's removal and replacement. It's not very friendly. You can do that when you have less than 2 or 3 meters of peat. Environmentally, it's not very friendly. But anyhow, it becomes very popular better because you eliminate the high compressibility of peat. The next one, which is gaining popularity, is bamboo mattress with geotextile. And then you can do surcharging and PVD for areas with soft clay, where you accelerate consolidation settlement, and you also can opt for the most expensive method, which is, they call it a method where you can't find a cheaper method, which is a pile embankment. In general, peats are soft and with very high moisture content, and it is difficult to access and move about during construction. And this is what you get when you try to actually move into peat and trying to do extensive earthwork without having to plan it carefully. But what you usually do in peatland is to dewater the land, like most agriculture. When they open up agriculture land, they would construct trenches, shallow, closely spaced drains to bring down the water table. When water table is drawn down, then you can actually allow machineries to go in. Or you can have 2 to 3 meters of deep trenches, widely spaced. And you can make the ground workable. You can bring in your machineries to start working on the ground. There has been works which have been undertaken where you pump sand into peat because there are no means of removing the peat entirely because they are too deep. Or you do bamboo mattressing to actually minimize differential settlement, and this allows for heavy machineries to come in and making total settlement or vertical settlement more uniform. The first on the left is total removal, but now it's getting more and more difficult to do because of the depth of peat is in excess of 2 to 3 meters. I would not recommend the progressive displacement and surcharging because the results would be unpredictable on the differential settlement. I would not go for the right-hand side option. Some of the methods which we have adopted in some of the construction in the country is to use partial replacement with PVD in the marine clay to accelerate consolidation and surcharging to achieve a certain degree of settlement before we proceed with the pavement works. This is another example where you incorporate the use of high-strength geotextile in the system. A pile slab foundation is the last option because it's the most expensive. It is basically to reduce the differential settlement. Some pile abutments are end bearing, some of them are frictional. The use of geotextile. I would like to show some of the two examples of the project undertaken by me in peat areas in Kota Biomas in Klang. This was undertaken in 2005, almost 10 years ago, when I met the chairman of the indoor lawn bowl, or rather the president of the lawn bowl, Malaysian lawn bowl at that time was, and still is, I think, Tan Sri Ahmad Saraji. He said to me, I've got an international competition next year. I want the stadium to be done in 1 year. And when I look at the site, I got a shock because it was covered with 2 or 3 meters of peat with soft marine clay. As you know, Klang is notorious for soft marine clay. It became a challenge to us. What we did was to create a platform where which is workable for machine to come in, and we installed PVD, and all is done within 2.5 months, which is about 10 weeks. And the ground was surcharged to accelerate nearly 70 to 80% of primary consolidation. After that has been achieved through our instrumentation, we did a waffle box raft. Waffle box raft is preferred because it's stiffer than a normal raft. Waffle raft is also preferred because of the economics. If it's not waffle, then it becomes very expensive because the volume of concrete would be too great, and the achievement of the stiffness of the slab would be quite similar to a thick raft anyway. And if you imagine doing an indoor lawn bowl, the criteria for any differential settlement would be very, very stringent. I can't have any settlement at all, differential settlement at all. So we create a very stiff raft to be able to cater for this, and absolutely no piles underneath the foundation. And this is what it is today. That picture was taken immediately after it was completed in 2007, and I think they were having national competition every year here in Kota Biomas. The other example which I want to show is in Chulan, one of the many projects that we have undertaken in peat and soft clay, is actually avoiding to actually getting very deep into peat. You have a very stiff fill layer. You know it's been recently filled, so you're going to have a lot of total settlement and differential settlement. It is for low-rise housing and landed property. You can actually opt for a rough foundation. A raft where it is shallow in nature but stiff enough to cater for any differential settlement. We have done quite a lot of this in Sime projects as well. And you can have a very pleasant double story. Of course, there is a little bit of conflict here. Engineers normally are being paid based on percentage fees. When I do cost savings like this, my fees becomes very little, getting less and less. So that works actually against me. I hope the Board of Engineers can review how the scale of fees can be done, and how engineers are more encouraged to actually do value engineering and sustainable construction in Peat. I think that was the last of my slide. Before I go, I have to do a little bit of sales on the guidelines which was launched this morning. There were 6 chapters on the guidelines. I think it took about 1 year to have done this, and I was fortunate. And lucky to be working with such talented and experienced engineers from the practicing side as well as from the academics, who are very, very committed workers, and we did it in 1 year as planned by CREAM and CIDP. These are the 7 chapters. Sorry, 7, not 6. 7 chapters that we had the guidelines. And just to mention, these guidelines, before it was launched today, it was presented to the industry on the 9th of September, where we call in all the stakeholders, the consulting engineers, we call in contractors, manufacturers to have a look at it. And the final refinement on guidelines was carried out immediately after that. And I think I need to mention that a Center of Research Excellence on Peat Soils, or CREEPS, is proposed to be established in Sarawak to undertake research and monitoring research study on construction.